Hi everyone, I'm Canoy together with my partner Prisms and Somblingo. We are assigned to demonstrate about the introduction of Book 3, which is all about the prisms from number 162 to 173. Prisms are three-dimensional closed surface that has two parallel faces called bases that are congruent polygons. Prisms are also called polyhedra since their faces are polygons. One of the example of prism is a cube, like this, because it has two parallel faces that is also called bases, this one and this one. And it is also called a regular prism because one of a right section, this one, is a regular polygon. A prismatic surface is a surface that generated by all lines that are parallel to a given line and intersect a broken line that is not in the same plane as the given line. For example, this is the broken line. It is also called the directrix of the surface. And the generator is the parallel lines or the moving lines around the surface. And the element of one of its lines is an element of the generator. And these broken lines is said to be generated of a closed prismatic surface. The basis of this prism is these two parallel cross sections which bound the prism. So if these two parallel cross sections are the basis of this prism, the other faces of this prism are called lateral surface. By the definition of a lateral surface, that it is the face of the solid on its sides that in any face or surface that is not a base. These are the edges of this prism, which are the lateral faces meet in a common line, or what we call edge of the prism. A right prism is a prism which the joining edges on the faces are perpendicular to the base faces. For example, these are the edges and these are the faces. These two edges are perpendicular to each other, and also the face of this prism are perpendicular to the base. Corollary 1. The lateral faces of the prism are parallelograms. This is the example of a parallelograms because it consists the properties of a parallelograms that are both pairs of opposite sides and opposite angles are congruent. Corollary 2. The lateral edges of the prism are equal and parallel. Example, in this prism, these two edges are equal and parallel. To prove that, I will measure these two edges using a ruler. So the measurement of this edge are 5 inches and 9 centimeters. On the other side, is also 5 inches and 9 centimeters. So they are already proved that they are equal. To prove also that they are parallel, these two lines or these two edges are parallel because according to the definition of a parallel, the two lines are parallel if they are not meet each other whenever they are extended.
Corollary 3. The lateral faces of a right prism are rectangles because a rectangle is a parallelogram with 4 right angles, and all the angles are 4 right angles. And this is the 4 right angles of a prism. Let's proceed to the kinds of prism. This prism is a hexagonal prism, and this is the quadrangular prism, and this one is a triangular prism. The naming of a prism is according to the shape, its base, and according to the orientation of the axis. The naming according to orientation of the axis is specifically used for right prism. For example, if the base of the prism is a pentagon, like in this figure, it is called pentagonal prism. Number 171, which is the altitude. The altitude of a prism is here, which is perpendicular to the upper base and the lower base. And it is also denoted as height. The lateral area is the sum of the areas of its lateral faces and the sides of prism. This is the side of a prism, or what we call the lateral faces. The total area of the prism is the sum of its lateral area and its bases. For lateral area, we only want to get the sum of lateral faces, but in total area, we include its bases. Truncated prism. A truncated prism is the part of a prism that lies between two non-parallel planes that cut the prism and intersect outside the prism. Let's say, for example, in this prism, this part is cut off by a plane meeting all the edges but not parallel to the base. Parallelepiped. A parallelepiped is a prism whose bases as well as lateral faces are parallelograms. Because according to the properties of parallelogram, both pairs of opposite sides and opposite angles are congruent, and their diagonal bisect each other. Rectangular parallelepiped has its bases and all its faces rectangles. For example, these bases of a rectangular parallelepiped and all its faces are rectangles because according to the properties of a rectangles, all the four angles are right angles and their diagonal are also right angles. A cube is a parallelepiped whose bases and faces are all squares. In this figure, we can see that all the faces of this cube are all squares, and we all know that squares are four right angles and four congruent sides. And according to the properties of a square has all the properties of every parallelogram.